Welcome everybody. In this video, I want to do a few more examples with adding and subtracting radicals. So the big thing with radicals when you add or subtract is they work very similar to variables. You need to have like radicals in order to add or subtract, just like you would need to have like terms or like variables. So for instance, in this first example here, notice how they both have the square root of 11 with them. So this is going to work very similar to an example like 4x plus 8x. We would add the 4 and the 8 together to get 12 and keep the x the same. We're going to do the same thing here. These are like radicals, so we're going to add the 4 and the 8, which is going to give us 12, and then we're going to keep the root 11 the same. Now, if you could simplify the root 11, of course, you would do that too. But the idea when you're adding and subtracting radicals is they do have to be the same exact type in order to add or subtract, just like we do with variables. Now, my next example, apologies for the mistake there. We're looking at the cubed root of 3x minus 7 times the cubed root of 3x. Again, notice that they're both the same kind of radical, right? Cubed root 3x, cubed root 3x. So we can go ahead and subtract these. Now, if you don't have a number out front, by the way, there is always a 1 there. So I'm doing 1 minus 7, which is negative 6. And then I'm just tacking on that cubed root of 3x. So again, just like you would with variables, that piece doesn't change when we add or subtract. Now, if you could simplify the cubed root of 3x, you definitely would. I can't do anything with it here, so this would be my final answer. Now, for the next example, you may be saying, okay, well, these are different, so I can't do anything, right? And you're sort of right. We can't do anything yet. But we do always want to try to simplify radicals. So if they're not matching right away, see if you can simplify them. Now, root 20, one of the factor pairs of root 20 is 4 times 5. And I notice I have a square root here. So I'm looking for a perfect square, and 4 is a perfect square. So I'm able to simplify this. 45 also has different factor options, but one of them is going to be 9 times 5. Again, I have a square root here, and 9 is a perfect square. So root 20 is going to break down into root 4 times root 5. Here, don't forget the 2, and then you have root 9 times root 5. And when I simplify, root 4 becomes 2. Root 9 becomes 3. So careful, you have 2 times 3 then, which is 6. And my problem becomes 2 root 5 plus 6 root 5. And now you're going to notice that, hey, I actually do have the same kind of radicals here, and I can go ahead and finish this problem. 2 plus 6 is going to be 8. So this actually does simplify to 8 root 5. The next one is going to be very, very similar. So notice I have all cubed roots, but they're all different ones. So I'm going to see if I can break these down and simplify first so that I can get them to match. So that's really our goal here with this. So let's see here. For the 54, again, you have to go through your factor pairs here, but 27 times 2 is one of my factor pairs for 54, and 27 is a perfect cube. So now I'm looking for cubes. For 16, 8 times 2 is one of the factor pairs that works, and 8 is a perfect cube. 2, I can't do anything with. It's just 2 times 1. So here, I would end up, let me switch to black for a second. I have the cubed root of 27 times the cubed root of 2 minus 5 times the cubed root of 8 times the cubed root of 2 plus 3 times the cubed root of 2. Now the cubed root of 27 is 3. So I have 3 cubed root of 2 minus. Now the cube root of 8 is 2, and there's a 5 here. So this is 5 times 2. This is all being multiplied. So that would be 10 with the cube root of 2 left, and then plus 3 and the root 2 as well there. Now notice that now they're all the same. Don't forget, if there's nothing out front, there is a 1. So I have 3 minus 10 is negative 7, plus 1 is negative 6. So this becomes negative 6, and then cube root of 2. All right, if you feel ready, this is a good place to pause the video and try the next example on your own. It's very similar to the last two we just did. Again, if you first look at it, they don't look the same at all. So you're going to have to just think here and break down. Now here we have all square roots. So you're looking for perfect squares here. So for that 27, I know that that's going to be 9 times 3, and 9 is a perfect square. 9 is already a perfect square, so I don't need to break that one down. And then for 72, that one is a little trickier. And let me think, 36 times 2 here should work. And 36 is a perfect square. So now if we break these down, I have the square root of 9 times the square root of 3. I'm going to leave the x under there as well because I can't really clear out the x. Then I have minus 2 times the square root of 9. I can definitely factor that out with the square root of x. And then square root of 36, and then square root of 2x here. All right. Now, square root of 9 is 3. So I have 3 root 3x minus square root of 9 is 3. So this becomes 2 times 3 is 6 root x. And the square root of 36 is going to be 6 root 2x here. Now, for this one, there's a couple different things that you could do here. So for your text at this point, it's telling you to stop because these are technically all different, right? Root 3x, root x, root 2x, they're all different. So this is a valid final answer because we can't break these roots down anymore. Another way you could do it, but it does get pretty messy. So again, you don't have to, is what you could do is you could write it like this. So I could break down that into root 3 times root x minus 6 root x plus 6 root 2, again, times root x. And then the only thing you'd be able to do there, and you could do it with parentheses, is you could write this as 3 root 3 minus 6 plus 6 root 2 all times root x. So you may see that more probably in advanced classes going a little bit further here, but again, it's really not even super helpful because even these values, I'd have to estimate with a calculator. There's no way that I can simplify those together here. So it just gets really messy. So at this point, because we've broken it down and they're still not the same, you can leave that as your final answer. All right, let's do a couple as well. Same process, but we're going to throw in a little bit of division or fractions here. Again, I see that root 45 and that root 5. So they're not in common. I can't just jump into subtracting things. So I'm going to start first by breaking it down. And I'm going to do the root 45 over here for a second. That would be 9 times 5. And I know 9 is a perfect square. So root 9 times root 5 gives me 3 root 5. So this first problem rewrites as 3 root 5 over 4 minus root 5 over 3. All right, so this looks much better. I now have like roots, and I can go ahead and start combining them. The other problem, though, is don't forget that fractions need common denominators when you add or subtract. So I also have to keep that in mind. I have a 4 and a 3 here, so I can use the common denominator of 12. So what I could do is I can multiply this first fraction by 3 over 3, and I can multiply the second fraction by 4 over 4. Be careful here. I have a 3 and a 3 again, so that's going to be 9. So I'm multiplying over 12 minus 4 root 5 over 12. So once I go ahead and do this, then I get 9 root 5 minus 4 root 5 all over 12. And finally, 9 minus 4 is 5. So we have 5 root 5 over 12 here. So this one's pretty tricky because you have to think about like roots, and then also don't forget that with fractions, you have common denominators. For this last one here, I am going to start by breaking this down a bit because I see that 8 in the bottom, and I know 8 is a perfect cube. So I'm going to write this first piece as the cube root of 7x over the cube root of 8. And then the cube root of 8 is just 2. So this becomes the cube root of 7x all over 2 plus 2 cube root of 7x. Now, the nice thing here is I am seeing like radicals right away. So I know that's a good thing. But just like the last problem, I need to have common denominators because this is a fraction. So this is normally over 1. If I want a denominator of 2 here, I'd have to multiply by 2 in the top and bottom. So this becomes 2 times 2 is 4. Keep in mind, too, that there is a 1 there. So now that we're ready, this becomes 1 cube root 7x plus 4 cube root 7x all over 2. And then 1 plus 4 is going to be 5. So our final answer is going to be 5 cube root of 7x all over 2. Now just be careful here as well. Watch those radicals because that x is underneath the radicals. So when you're typing your answer or when you're writing an answer out, make sure that that x in this particular example is clearly underneath, right? So it's really easy to kind of mix those up and just write messily. So make sure you're writing really neatly or you're typing really neatly and watching where your variables are. Are they inside the root or are they outside the root?